Hello students, welcome to Wondercom. In this video, I will discuss about the modern periodic law as well as the long form of periodic table. Just to overcome the drawbacks of MENDELEEV'S periodic table, mostly put forwarded this modern periodic law. So let's discuss about the fact which initiated mostly to put forward this law. He actually observed the X-ray spectra of different elements, and he found a straight line when he plotted square root of frequency of the X-ray against your atomic number of the elements. So, he couldn't find such type of observation when he has taken atomic weight of the element. So, he established that atomic number of the elements are more fundamental, or these are the fundamental properties of an element than that of the atomic weight. And based on this, the modern periodic law was established. And the law states that the physical and chemical properties of element are the periodic functions of their atomic numbers. This law provided important comparison between 94 naturally occurring elements, and also it helps in creating new artificial short-lived elements. So, based on this modern periodic law, many forms of periodic tables have been made, which are based on either chemical reactivity or valencies or electronic configuration. But at last, the most convenient and widely accepted form of periodic table was the long form of periodic table. This is the long form of periodic table. So the main features of this table are, it consists of vertical columns. These are the vertical columns known as groups or families. There are 1 to 18 groups in this table. Similarly, the horizontal lines are the periods, and there are 7 periods in this periodic table. First period contains 2 elements. This is the shortest period, contains hydrogen and helium. Second and third periods contain 8 elements each. So second period starts from lithium to neon, and third period starts from sodium to argon. Similarly, the fourth and fifth periods contain 18 elements each. This is fourth starts from potassium to krypton, and fifth starts from rubidium to xenon. Then the sixth and seventh period contains 32 elements each, where in the sixth period, lanthanoid series is there with the 14 elements from 58 cerium to lutetium, and here in actinoids are present from thorium 90 to lawrencium. So those 14 elements from lanthanoids as well as actinoids are kept below the periodic table. So next feature of this periodic table is that it contains different blocks depending on the subcell, S orbital or P orbital or D orbital and F orbital. According to that, it has S block element, P block element, and D block as well as F block elements. This is based on the electronic configurations of the elements. This periodic table also arrange the elements according to the characteristics, like whether they are metals, non-metals or metalloids. So this you can see the elements which are present in blue color, they are metals. The pink color portion, right hand side of the periodic table, the elements present are the non-metals as well as the hydrogen here, and this zigzag line in yellow color, the elements which are present, they are metalloids, that is the intermediate between metals as well as non-metals. Here we'll see the arrangement of electrons in the first period, that is for hydrogen and helium. Electrons are occupying in the first cell or the K cell in case of hydrogen and helium. Similarly, in the second period, n is equal to 2, and the electrons of these elements are occupying the second cell or the L cell. from lithium to neon. And so also in the third cell where n is equal, third period where n is equal to 3, so the electrons from sodium to argon, they are occupying the third shell or the M shell. Here one more information that we'll get, that the valency of the elements. See, because this periods also tell about the outermost shell or the electrons which are present, that is valence electrons. So the valence electrons or the valency of the elements depends on the valency electron. You can see in this, in case of hydrogen and helium, so electronic arrangement is like that. So in case of hydrogen, it can share one electron, so the valency is equal to 1. You can lose or share. So the in case of helium, it is a completely filled fast shell. So this is a very stable form. So its valency is 0. So along with the valency, it also the periodic periods also tell about the reactivity of all the elements. In case of the second period, the lithium to neon, see this is the electronic arrangement in the shell. And this is the valency. Either they will lose electron. If one electron is there in the valence cell or the outermost cell, then its valency would be 1, and by losing one electron, and if 2 electrons are there, they can lose 2 electrons. That element or this beryllium is having valency 2. But in case of carbon, 4 electrons are there in the valence cell or the outermost cell, so it can share 4 electrons. Its valency is 4. In case of nitrogen, it can either gain 3 electrons or share 3 electrons, so its valency becomes 3. And for oxygen also the same, so it can gain 2 electrons or it can share 2 electrons during the formation of compound or bonding formation, so its valency is 2. So also in case of fluorine, it can gain or share 1 electron, so its valency is 1. Whereas in case of neon, it is having completely filled shell, L cell, so it is the stable form or having as per the octet rule. So the periodic table can also give information about the reactivity of different elements. So that can be known from their valencies. As we just discussed, the elements can lose or gain or share electrons, and from that we can know about the valency of different elements. So you know, by losing electrons, the elements or the atoms becomes ions, that is positively charged. For an example, in case of sodium, by losing 1 electron, it becomes Na+. Similarly, for magnesium, by losing 2 electrons, it becomes Mg2+. And what about Cl-? So by accepting 1 electron, the chlorine becomes chloride ion. So its valency is 1. Sodium, valency of sodium is 1 because it is losing 1 electron. Similarly, the valency of magnesium is 2 because it is losing 2 electrons. Whereas chlorine, it is accepting 1 electron and becomes Cl-. And for oxygen, it becomes oxide, or by gaining 2 electrons, it becomes O2-. If you marked, I told you sharing of electron, that in case of your carbon. So in case of carbon, it has 4 electrons in its valence cell. I am just telling about the valence cell, outermost orbit of carbon. It consisting of 4 electrons. So it can share 4 more electrons. Suppose in case of this methane, we'll discuss about methane, how it forms. So hydrogen have only 1 electron, so both hydrogen and carbon, they are sharing this. This is for hydrogen, then another hydrogen, it is having the X for the electron of hydrogen, I am just putting here. So this is one more hydrogen. So hydrogen is sharing 1 electron with carbon. So carbon is also sharing 1 more this electron with the hydrogen. So this is the sharing, and we get CH4H. Okay, so it becomes your CH4. This is your sharing. So here the valency of carbon is 4 because it is sharing 4 electrons with the 4 hydrogen. Again, this losing of electrons will tell about the metallic character of the element. So as we move from left to right of the periodic table, the metallic character decreases. As the number of electron is increasing in the outermost cell, so it is difficult to lose electrons. So the losing of electron decreases, so also the metallic character. Whereas in a period, the metallic character increases as we move down the group. It is because the outermost cell is is moved away from the nucleus. So it will be easy for the element to lose electrons or the outermost electrons to become positive. So metallic character increases along the group and it decreases from your left to right in the period. The next important information that we get periodic table is the atomic or ionic sizes. Atomic or ionic sizes, that means this depends on the radius or radii of different elements. The radius of the atom is nothing but the distance from the center of the nucleus to the outer cell. Center of the nucleus to the outer cell. This is the radius of the atom. Just have a look of the atomic radii of different elements in the group as well as period. See in the group how the trend, it is increasing here as I told you, and in this period it is gradually decreasing, isn't it? So this is how this trend for the atomic size or radii of different elements are in this order in the periodic table. Let us summarize the importance of the periodic table. We'll first start with the effective nuclear charge. Effective nuclear charge. That is the force of attraction between the nucleus and the valence electron. This is the force of attraction increases as we move from left to right in the periodic table. So the atomic size also decreases because there is force of attraction from the nucleus to the outermost electron, it pull inward. So the size decreases and the tendency of losing electron also decreases as we move from left to right. So the elements which are present in the left hand side of the periodic table are more metallic, and the metallic character decreases as you move from left to right in the periodic table. So also the formation of positive ions. And the tendency of accepting electron increases as we move from left to right. So that means here whatever the elements which are present in the right hand side of this periodic table can accept easily the electrons. That means the non-metallic character increases as we move from left to right. The metallic character decreases, non-metallic character increases. Similarly, in case of a group, the effective nuclear charges decreases. It is decreasing, here more, here it is decreasing. It's because number of cells, additional cells are increasing here as we move down the group. So the effective nuclear charges decreases. So it has less attraction to the outermost electron. The nuclear has less attraction, so atomic size increases. Tendency of losing electron increases, so also the metallic character increases. But the non-metallic character decreases as we move top to bottom of the group in a periodic table. As a result, the non-metallic character decreases. Metallic character increases, non-metallic character decreases. So for the time being, this is all about the long form of periodic table and its importance. And I will be discussing more about quantum numbers, electronic configuration, and periodicity, and many more the things like ionization, enthalpies, electron affinity, etc. in my next video. So keep watching and keep learning. Thank you.